Welcome to Two Projects. In this video, we are going to explain about the project that is an explainable artificial intelligence model for the classification of breast cancer. So before getting into the execution, first let us understand what is this project about. Breast cancer, which is the most common cancer among worldwide women. Though men can get it too, just much less often. It happens when cells in the breast start growing uncontrollably, forming malignant tumors. The really important part is that detecting it early makes a huge difference. Treatment is more effective and the chances of survival are much higher. So, traditionally, doctors use mammograms, that is, mammograms, which are X ray images of the breast to check for the cancer. But these tests can take time and sometimes they give false positives, meaning they indicate cancer when there isn't any. This can cause unnecessary worry for the patients and even lead to procedures or biopsies that weren't needed. So, artificial intelligence models, that we call it as AI, and machine learning models have really shown a lot of promise when it comes to helping detecting breast cancer more accurately. They can analyze complex data and spot patterns that might be missed by humans. But here the problem is a lot of these models work like black boxes. That means they give a result like saying a tumor is malignant or benign, but they don't really explain how they came to that conclusion. So, because of this, doctors and healthcare professionals sometimes find it hard to fully trust these predictions. If they can't understand how the model is making its decisions, they may be hesitant to rely on it, which can slow down the adoption of AI tools in real world medical settings. So, here, the main challenge here is to create a system that does more than just telling us whether a breast tumor is benign or malignant. We also want to explain why it made that decision. This is really important because doctors need to understand the reason behind the prediction to make the best decisions for their patients. So, by making the model interpretable, it can show which features like certain cell characteristics or tumor size are most important in determining whether a tumor is cancerous. This not only helps doctors diagnose more accurately but also supports better treatment planning and gives a deeper understanding of the disease itself. So, here, the system we are proposing is basically a machine learning model that can help diagnosing breast cancer, but with a twist, it is explainable, which means it doesn't just give an answer, it also shows why it made that prediction. So, to do this, it uses structured databases. That is, Wisconsin breast cancer dataset and Wisconsin diagnostic breast cancer datasets. These datasets have important information about tumors such as their size, shape, texture, and other cell characters, which the model analyzes to figure out whether a tumor is benign or malignant. So here, the system, it works by using different machine learning models that are K nearest neighbor and ANN, that is artificial neural network, to figure out whether a tumor is benign or malignant. And it does with clearly high accuracy. But this doesn't stop here. To make sure doctors can trust the results, the system uses explainable AI techniques, that is, permutation importance, sharp values, and line. These methods basically show which features of the tumor, like size, texture, or cell characteristics, had the biggest impact on the prediction. By combining accurate predictions with clear explanations, this system not only helps detect breast cancer early but also supports doctors in making informed decisions and planning the best treatment for patients. Moving on, as the extension, to further improve the performance of this project, this project incorporates machine learning models to make predictions even better. So it includes decision tree, ADA boost, and a ensemble model, that is voting classifier, which basically combines several models together to give a reliable result. By using multiple approaches, the system improves its accuracy and make more confident predictions about whether a tumor is benign or malignant. And in addition to the machine learning models, we have also built a web application using Flask. For that, we have also added user authentication so that it is secure. This means user can log in and enter their information to get predictions from the trained models. The idea is to make the system easy to use and accessible so it can actually be applied in situations to help with the breast cancer diagnosis. Moving on to the implementation, to implement this project, we have followed the steps which are mentioned in flow of work. So let's understand how we have implemented the project. First, we bring all the necessary libraries that will help us work with the data, build machine learning models, and also create visualizations. Then comes exploring the dataset part. So here we will be loading the datasets, both the datasets that are WBC and WDBC, that are Wisconsin breast cancer dataset and Wisconsin diagnostic breast cancer dataset, and understand what kind of information they contain. Coming to data visualization, so we visualize the data to get a better understanding of it and check how the target classes are distributed and plot a correlation matrix to see how different features relate to each other. Then comes data pre-processing. Here we clean and prepare the data for models. We will be removing duplicate values, encode categorical features into numericals, that is numbers, split the data into input features and the target variable. Then we will be splitting the data into train and test sets where training set is used to train the model and testing set is used to evaluate the model. And then we will be building, that is, we will be initiating and training multiple machine learning models to classify tumor and that are benign and malignant. And then we will be evaluating all the models using accuracy, precision, recall, and FN score. And we will be visualizing all the performance scores through graphs. And we will be saving the best performing model for the future use. For interpretability purpose, we are using Lime and SHAP to show the model implementation, to show which feature contributes more for the prediction. Moving on to the front end, here we have developed front end of this project using Flask, which is also integrated with SQLite database for registration and login purpose. And users will be able to provide feature values in the input. As the input, that will be pre-processed at the backend. It will be fed to the train model, and train model will be predicting whether the person has breast cancer or not. That is whether it is benign case or a malignant case. And these are the models used. These are the algorithms which are used in this project to predict the breast cancer. And to implement this project, we need hardware and software requirements. In hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute. To execute, open the code folder that contains source code files. So let's open it. So these are the source code files of the project. Let's understand each of them. In this folder, we have the two data sets that are used. So we have WBC and WBDC. Let's open this WBC. So here, these are the features of WBC, and here we have class. 2 refers to benign and 4 refers to malignant. And these are the independent features that impact in predicting breast cancer. And we will be training the data set for predicting breast cancer. And here we have WBDC. Here we have multiple features, multiple attributes for predicting whether the person has breast cancer or not. So this is the prediction column, that is the target column that we will be predicting. And here we have ID of the people. Let's close this, get back. This is the model folder in which we have algorithm information that will be loaded into the project code during runtime of the application. And here we have static folder in which we have CSS, JavaScript, and Bootstrap file which are important for the visual appeal. And here we have templates folder which contains HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have test cases. In this, we will be having sample cases that we will be using in the front end. And here we have app.py file. So this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have signup.db file, that is a database file which is used to store the user information. And here we have two Jupyter Notebook files which contain combination of code, graphs, and outputs all in one place. It allows us to write code in individual cells and also run the code. That is, it allows us to generate the code, it allows us to write the code, graphs, and outputs all in one place, and it allows us to write and execute code in individual cells, making it a popular choice for the data science. And here we have processed dataset files. Now let's execute it. To execute, open the code folder. I mean, copy the path of the code folder from the address bar of the file explorer. So I'm copying the path, copy it. Now open Anaconda prompt. It is open. Give the command cd, give the space, paste the copied path, click on enter. Click on enter. So here you can observe current directory is changed to the code folders path. Now compile app.py file. So give the command python space app.py and click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port. So this is the local host and this is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. I'm copying it. I prefer Chrome, so I will paste it in that. So paste the link here, click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So this is the web page of the project. Now click on explore now. Click on explore now. And here you need to create an account. After creating an account, you can log in. I have already created account, so I'll directly sign in. Click on sign in and give your username and the password. Click on sign in. We have signed in successfully and redirected to prediction page of the project. So here we will be doing prediction for the two data sets, that is WBC prediction and WDBC. First, let's do prediction for WBC. And here you can see some features that are need to be entered for predicting whether the person has breast cancer or not. So the first one we have is clump thickness. So clump thickness, it measures how thick the group of cells in the tissue sample is. Higher values can indicate abnormal cell growth. Then we have uniformity of cell shape. So it this looks at how similar the cells are to each other in shape. If cells vary a lot in shape, it can be sign of malignancy. Then we have marginal adhesion. This checks how well the cells stick to each other. Low adhesion means cells are more likely to spread, which is common in cancer. Then we have single epithelial cell size. So this measures the size of the individual that is epithelial cells. Larger or irregular size can suggest abnormal growth. And then we have bare nuclei. This counts the nuclei that appears without surrounding cytoplasm. More bare nuclei are often associated with the malignant cells. Then we have bland chromomet, that is chromomatin. This evaluates the texture of the cell chromatin, that is the material in the nucleus. Coarser or irregular chromatin can be a sign of cancer. Then we have normal nuclei. This looks at the presence and the appearance of the nuclei in the nucleus. Abnormal nuclei can indicate rapid or irregular cell division. Then we have mitosis. Mitosis, this counts how many cells are actively dividing. A high number of mitosis can indicate aggressive tumor growth. So this is all about the parameters. Now let's enter them. So open test cases. So let's open test cases. Open sample WBC. So let's start entering them. Here we have class 0 and class 1. So these are the test cases of WBC. And here we have multiple parameters. So the clump thickness is 5. And uniform cell shape value is 1. Marginal adhesion is 1. Singular epithelial cell size is 2. Bare nuclei is 0. 3 is bland chromatin. Normal nuclei is 1. Mitosis is 1. Now click on classify with XAI. We have missed some features. So bare nuclei, it is 0. Value must be equal to or greater than 1. So let's give it as 1. Now click on classify with XAI. So here we got the prediction that the analysis suggests no malignancy. Here you can observe there is no malignancy for the person with the 97.0 confidence score. And here these are the cell characters. So analysis of the 8 key cellular features including clump thickness, uniformity of cell shape, marginal adhesion, and the other critical parameters. So these are the cell characters. And AI model performance, here we have explainable AI, and here we have key contributing factors, which are clump thickness is the high impact, uniformity of cell shape is also giving us the high impact, and all these three are the low impact. So based on these two characteristics, the application is able to qualify that it is no breast cancer. The person has no breast cancer. And here we have clinical recommendations. Here you can observe there are clinical recommendations. Now you can also print the report, and here is the important disclaimer. Now let's do the other analysis. Click on new analysis. Now let's check with this case where clump thickness is 5, uniformity of cell shape is 4, marginal adhesion is 5, 7, paired nuclei is 3, 2, 1. Sorry, we have missed something. So let's recheck. 5, 4, 5, 7, 1, 3, 2, and 1. Click on classify with XAI. And here we got the prediction that it is benign. The analysis suggests that there is no malignancy. That means person has breast cancer tumor. That means he has a tumor, but it is benign. That means it will not spread. It will not cause any harm. Here we have confidence score of 63.2%. And here we have the cell characteristics. AI model performance, explainable AI. It is showing that key contributors are clump thickness, uniformity of cell shape. So these are the medium impact. And here we have clinical recommendations. Now click on new analysis. Let's check with this case where clump thickness is 8. Then we have 10, 8, 7, 1, 1, 9, 7, 1. Click on classify with XAI. So here you can observe malignant. The analysis suggests that it is malignancy. That means person has breast cancer tumor cells where that is very harmful. It has to be treated. So here we have 100% of confidence score, and here we have all the analysis. Now click on new analysis. Let's do analysis with this case where clump thickness is 9, uniformity of cell shape is 8, marginal adhesion is 1, 2 is the single epithelial cell size, bare nuclei is 3, bland chromatin is 2, and here we have normal nuclei, it is 1. We have missed something again. So let's recheck. 9, 8, 1, 2, 3, 2, 1, 5. Now click on classify with an XAI. And here you can observe malignant has been predicted. That means person has breast cancer, it has to be treated. With the 95% zero score, it is giving the prediction. Let's check with the other data set. So click on WDBC prediction, click on that. And here also we have some parameters that are need to be entered. So let's see what are these. The first one we have is the radius burst. So this measure, that is, this measures the largest radius of the tumor cells in the sample. Higher values can indicate larger or more abnormal cells. Then we have texture worst. This looks at the roughness or irregularity of the cell surface. High texture values can point to abnormal cell growth. And here we have perimeter worst. This calculates the largest perimeter of the tumor cells. A bigger perimeter often corresponds to the irregular or malignant cells. Then we have area worst. This measures the largest area occupied by the cells. Larger area can indicate a big tumor or more aggressive growth. Then we have smoothness worst. So this checks how smooth or rough the edges of the cells are. Rougher edges are often seen in the malignant tumors. Then we have compactness worst. So here we have compactness worst. This measures how tightly packed the cells are. Higher compactness can suggest abnormal clustering of the tumor cells. Then we have concavity worst. So this looks at how indented, that is how intended or concave the cell shapes are. More concavity can indicate irregular or that is irregular and potentially cancerous growth. Then we have concave points worst. This counts the number of concave points along the cell boundaries. More concave points usually indicate abnormal cell shapes. Then we have symmetry worst. So this evaluates how symmetrical the tumor cells are. Less symmetry can offer the points to malignant growth. Then we have fractional dimension worst. This measures how complex the shape of the cell is. High values suggest more irregular and potentially cancerous cells. This is all about the parameters. Now let's enter them. Let's open the file. So this is the sample file. Let's start entering them. So let's apply filter to benign case. and check with these values, where radius burst is 15.11, copy it, paste it, and then texture burst is 19.26, perimeter burst is, so here perimeter burst is 19.99.7, paste it, and then we have area burst, that is 711.2, smoothness burst is 0.114, then we have compactness burst, it is 0.1773, and then we have concavity burst, paste it, then we have concavity point burst 0.128, symmetry burst is 0.2977, and then we have fractional dimension burst. Now click on classify with XAI. Here input will be pre-processed at the backend, it will be fed to the train model, and then train model will be giving us the prediction. So the train model is predicting it as benign. The analysis suggests no malignancy. That means the person has no malignant tumors, that with a 99.56 confidence score. And here are the cell characteristics, where analysis of 10 key cellular features, including radius, texture, perimeter, area measurements from the worst case scenarios. And here we have AI model performance. So the key contributing factors are radius burst and concavity burst here. Area burst, perimeter burst, and compact burst are of medium impact. So this is extracted with the explainability features, that is Lime, Shap, and perimeter burst. Now let's check with the other case. Click on new analysis. So let's check with this case. So copy the radius burst, and then texture burst is 20.7, perimeter burst is 89.88, area burst is 582.6, smoothness is 0.104, that is 194, and then we have compact burst, that is 0.2156, concavity burst is 0.305, concave point burst is 0.06, and then symmetry burst is 0.27, fractional dimension is 0.83. Now click on classify with XAI. And here you can see the model is predicting it as benign with a 99.97 probability score for predicting this benign class. Now let's check with malignant. Click on malignant, apply filter to it. So click on new analysis. Let's check with this case where radius burst is 25.38 and texture burst is 17.33. Perimeter burst is 184.6. Area burst is 2019. And smoothness burst is 0.1622. Compactness burst is 0.6656. Then concavity burst is 0.719, 7119. Concavity points is 0.2654. And symmetry burst is 0.46. Fractional dimension burst is 0.1189. Now let's click on classify with XAI. And here we got the prediction as malignant. That means the analysis suggests that person has malignant breast cancer tumor. That means the tissues are malignant type. That means which are very harmful. It has to be treated with a confidence of 99.15%. And here are the key contributing factors, which are extracted with the permutation factors of the explainable model. Now let's check with the graphs. So let's check with the graphs of WBC analytics. Here we have sample outcome graph. Here on x-axis we have benign and malignant case, and on y-axis we have count, which shows the class distribution. And here we have correlation matrix, which shows the correlation between individual features. Here we have confusion matrix, where on x-axis we have predicted level and on y-axis we have true class, and this is the ROC curve extension of voting classifier. And here we have accuracy score comparison graph. On x-axis we have all the models that we have trained, and on y-axis we have accuracy. Here we have precision score. Here we have recall score. And here we have FN score. Here we have permutation importance plot graph. This is the explainable AI graphs, which is permutation importance plot for the WBC dataset. Here you can see clump thickness, normal nuclei has the highest importance. Close it. Here you can see sharp explainable graph. Close it. Now let's check with the graphs of WDBC. So this is a sample outcome graph. This is the correlation matrix. Here we have confusion matrix and ROC AUC. Here we have accuracy score, precision, recall, and here we have FN score. And here we have the permutation importance plot of WDBC where concave points versus texture versus area versus has the highest importance. Close this. And here we have XAI sharp explainability graph. Close it. Now click on logout. So this project shows how technology can help in detecting breast cancer early and more reliably. It not only predicts results but also helps doctors understand the reasons behind them, making treatment decisions easier and giving patients a better chance at recovery. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.